Howdy, everybody. Our project is over coastal corrosion and infrastructure. It is by me, Diego Alvarez, Peyton Lederman, Reinhard, Van der Westhuizen, and Anna Morrison. Firstly, we'll be looking at what this project is about. Our project examines how salt and moisture in the coastal environments accelerate corrosion and infrastructure, specifically coastal power supply systems. Power infrastructure in these areas is exposed to high sea salt levels and humidity, which greatly increases corrosion rates. This leads to frequent maintenance issues and, more critically, compromises the reliability and lifespan of these systems. So, why does it happen? Really, it just comes down to the chemistry. Salt in the coastal air contains chloride ions, which act as electrolytes, speeding up in the oxidation process, which breaks down metal. Moisture adds to the problem by creating ideal conditions for corrosion cells to form, further accelerating metal degradation. Over time, this increases the rate of oxidation and weakens the structural integrity of key power infrastructure. Our focus in this project is to explore engineering solutions that can help mitigate these issues. We're looking at strategies like advanced protective coatings, cathodic protection systems, and regular maintenance schedules. These measures are designed to slow down the corrosion process and ensure that power systems in the coastal areas remain durable and reliable. By focusing on these engineering solutions, we aim to extend the life of coastal power infrastructure and improve its resilience to harsh coastal conditions. Ultimately, this work isn't just about reducing maintenance costs, but also about ensuring a stable power supply for communities along the coast.
What are the duties and agreement between the group members? Diego is the team manager. The team manager guides team members to find a final project by overseeing all other team roles. Adam is the team facilitator. The team facilitator organizes meetings and group due dates. Reinhardt is the research facilitator. The research facilitator ensures individual team members complete efficient and relevant research. Peyton is the product manager. The product manager guides fellow team members on actual video presentation content. So agreements we made between each other include 6 rules and how we deal with conflict. The 6 rules, the first rule is that we must respect each other and each other's time. The second rule is that we must complete our work on time. The third rule is that we have to be on time for meetings. The fourth rule is that we have to be present during the meeting, so no zoning out and not being distracted. The fifth rule is to use GroupMe as for primary communication. The last rule is to be inclusive so no one feels out. And how we deal with conflict if conflict occurs between 2 team members, we'll first try to mitigate it by having someone else try to resolve the conflict. If that doesn't help, we'll get someone outside the group to resolve the conflict. So our 4 initial proposals were: first, increase oxidation around shipping by the coast by Adam, which was about how the coast increases oxidation, and especially on ships. A way to solve this problem is to find a better alloy that oxidates at a slower rate. Then carbon emissions by shipping industry by Diego, where shipping produces one of the largest carbon emissions in the world. A way to solve this problem is to use cleaner fuel sources such as nuclear powered ships and biofuel powered ships. Then we have the wear and tear on our infrastructure by Reinhard, where our infrastructure is slowly falling apart due to the increased oxidation around the ocean. A way to solve this problem is to create/find a material or design that's more resistant to the ocean. And finally, erosion by Peyton, where it's a major problem around the ocean as it can cause damage to buildings and beaches. The way to solve this is to create a natural barrier that stops the waves or current from eroding the coastline, like an oyster reef or rock reef. We chose the corrosion affecting our infrastructure problem as it's most relevant to our majors.
3 seconds now.
Okay, so for our findings along our boat trip, the first picture shows that by highlighting a recently repaired bridge, that it rusts extremely quickly. This is because of like the elements it's exposed to. Additionally, in addition to salt and humidity from the sea. Now, why are you thinking, why is corrosion bad? Well, it's, as Diego mentioned earlier, it's because corrosion weakens the structure's integrity over time. And one example where this is shown very well is picture 2. As we see an old ship, this is actually USS Selma, that corroded over time, which highlights the severe degradation of a once functioning ship. It's not only ships and bridges, however, as oil rigs, as shown on picture 3, also faces the same problem. When we were on the boat trip, we saw that the oil rig was extremely corroded, as you can see at the bottom there, due to the harsh saline environments. This could inevitably lead to weakened structures that could lead to potential accidents. This leads me to number 4, which highlights how susceptible bridges are to metal, specifically around the joints, just like the previous one, which over time could make the bridge slower and just harder to move in general. And after combining all this, it's extremely obvious that this lines up very well with our proposal. The reason I say this is that we kind of found out that the increased oxidation in conjunction with salt and increased humidity was a major problem, which we see in the pictures right now, and is a direct indicator that increased corrosion rates throughout all major infrastructure, including bridges, ships, ports, and more, is an issue that we need to solve. Thank you.
What is your specific evidence from the literature? To begin, our resources and literature offer strong support for understanding and addressing the complexities of corrosion. We consulted with many sources, such as an academic journal, which the analysis of metals corrode differently in specific environments. These studies emphasize that corrosion is not a one-size-fits-all issue, and vary significantly with environmental factors, underscoring the need for the tailored solutions in coastal areas. We also reviewed an article about how corrosion led to a tragic collapse of a bridge, showing how infrastructure failure can result from the unchecked progression of corrosion. Now, how do scientists and engineers approach this problem? There are several scientific areas involved in addressing coastal corrosion. Material science, for example, works on developing corrosion-resistant alloys and advanced polymers. Corrosion engineering tackles real-world applications of these materials utilizing coatings and technologies like catalytic protection to prevent metals deterioration. Does this issue affect the marine environment? Absolutely. Corroding infrastructure releases metals and chemicals into coastal ecosystems, affecting water quality, marine habitats, and local biodiversity. Infrastructure also plays a crucial role in marine environments by supporting flood prevention, shoreline stability, and environmental conservation. When infrastructure deteriorates, the benefits of it are compromised, ultimately harming the ecosystem it was meant to protect. How should engineers address this problem? Engineers should focus on carefully picking material and selecting an innovative design, and regularly maintaining and monitoring. Choosing materials that withstand salt water, designing structures with built-in redundancy to prevent collapse, and performing routine inspections are all vital to the impact of the corrosion's impact on the building and structures. So what's the best path forward? A holistic approach is key, combining advancements in the material science, protective technology, and strategic design can create resilient infrastructure that better withstands coastal corrosion. By understanding the science and implementing these solutions, we can protect both human safety and the marine environment for the severe consequences of corrosion.
All right, guys. Well, thank you for watching. And of course, once again, Giga Maggies.